The key to a large aspect of clam physiology is the movement of water. Water comes in an inhalant siphon. It passes through the mantle cavity where the gills are. It will leave through an exhalant siphon. And this then also helps the processes of digestion, excretion, and reproduction. So in this animation, you can see that there are these siphons which can extrude from the shell of the clam. Even if they are buried, these siphons then could penetrate the sediment and be the only part of the clam which is visible. Water then comes in through an inhalant or incurrent siphon and will ultimately pass out of the clam's body through the exhalant or excurrent siphon. While the water passes through the mantle cavity, the mantle being the epithelia which secretes the shell, this water then can pass through the gills because the demibranchs of the gills have ostia or openings so that water can pass through and eventually through water tubes, which will then pass into the space which communicates with the exhalant siphon so that water can then leave the clam's body. Now, not only does this allow gas exchange to occur in the gills, but also this allows for food particles to enter the clam. So clams are filter feeders. Large mussels can process several gallons of water a day as water comes in and they take out algae, bacteria, and sediment. And so that they are purifiers of water. If you have a muddy tank and add clams, the clams will then filter the water and the water becomes clear because they are sucking in the water and removing the sediment, and they feed on the algae, the microorganisms, and the detritus which is in this water. The gills are lined by cilia, and then these particles can be swept by the cilia towards the mouth and ingested. And so this movement of water not only helps with respiration, but also with feeding. Also, excretory waste can then be added to the water, which is pumped out the exhalant siphon, as can gametes. And so the expulsion of water from the clam can help in reproduction. In some bivalves, such as mussels, the larvae remain inside the mantle cavity of the parent and are released in the larval form of Glaucidia. So larvae can be expelled after maturing inside the body of the parent. And mussels rely on fish to transport the larvae in their gills. And so the larvae are ectoparasites for about a week or so before they dislodge and then find a place to fix on the bottom. And so the adult mussels may expel the larvae, the Glaucidia, when they sense the presence of a fish, with the idea that this allows the larvae to fix in the fish gills so that they can be transported.